Hello, we're going to start our first video off with a quick review of derivatives. So our first problem here, we've got the natural log of 5x squared plus 3 minus x cubed plus 4x to the fifth. So both of these terms, we'll take the derivative of each of them individually, but both of them are going to require us to use the chain rule. We're going to need to take the derivative of our outside function. So in the case of the first term, our natural log, in the second term, that to the fifth power, and then multiply by the derivative of our inside function. So derivative of natural log, we can write that rule over here, that helps us out. Derivative of natural log is 1 over x, so we'll have 1 over what's inside of our natural log times the derivative of that function that's inside of our natural log. So we'll get 1 over 5x squared plus 3 times 10x, and then minus 5x cubed plus 4x to the fourth. So the derivative of that exponent of 5, bringing the 5 down, taking away 1 from that exponent, and then times 3x squared plus 4. So really we can leave it like this if we want. It's basically done. We've taken the derivative. If we want to, simplify it just a little bit, make it look nicer, it's not even simplifying. It's really just making it look nicer. This is about it. We could write that first term all as one fraction, and there's not much we can do with that second term. Things to be careful about here is we can't cancel that 10 with that 5 on the bottom because it's not in both terms. We'll see here in the next example a time where we can cancel on the top and the bottom of the fraction, but we need to be able to factor that 5 out of all of the terms on the bottom if we want to be able to cancel, and we don't have that, so we can't. So let's take a look at the next example. We've got one here where we need to use the quotient rule because we have two functions that are divided by each other, cosine of t and t to the third power. So let's use our quotient rule. So we've got the derivative of our top function, which the derivative of cosine is negative sine, then times that function that's on the bottom, minus the derivative of the bottom function, times, oops, it's not sine, it's cosine, times the derivative of, or the original top function, sorry about that, and then the bottom function squared. So this one, again, it's basically done. There is some simplifying that we can do on this one if we want to, because we've got a t to the third in our first term here and a t squared in our second term. So if we want, we could factor out a t squared. So we'd be left with minus t sine of t. I like to write that variable in front of my trig function. Just looks a little nicer. And then minus 3 cosine of t. And then this will be over, we've got t to the third times t to the third, so that's t to the sixth. So we can cancel our t squared with our t to the sixth, and that leaves us with t to the fourth. So we can cancel on this one because we can factor that t squared out of the entire top function. It's in all the terms, so we can factor it out. So if you can't factor it out of everything, you can't cancel it. You can't cancel just in one term like we had up in this problem here. We'd have to also have a 5 that would be, sort of sitting there hidden with, being multiplied by that 3. So back down to the problem we're doing, our overall answer is going to be that negative t sine of t minus 3 cosine of t over t to the fourth. So then kind of looking ahead or thinking about what are the things that we're going to need to make sure from 251 that we have memorized. And there's a couple of things, of course, the product, quotient, and chain rules. Those are very important, particularly chain rule. That's something that we're going to be seeing a lot of here in 252. But just as a reminder, the product rule, we've got that first function, derivative of the first function times the second, derivative of the second function times the first. I don't know if you can hear my cat meowing in the back. It's really, really cute. Just coming in to say hi to you guys. our quotient rule. So remember, quotient rule, the top of the quotient rule looks an awful lot like the product rule, but with a subtraction instead. And then we've got that divided by our bottom function squared. And then the chain rule, that's when we've got a composition of functions. And so we get f prime of g of x times g prime of x. So the derivative of that outside function times the derivative of the inside function. Of course, we also have our power rule, which we used earlier. If we've got x to a power, oh no, I'm going to run out of space. Move things over just a little bit. There we go. We bring that power down in front, and then we take away 1 from our exponent. So power rule's good. In terms of trig functions, I always say it's good to remember sine, cosine, and tangent. But even if you don't remember tangent, you can find it if you know the derivative of sine and cosine, and you can use the quotient rule. You can use this as sine over cosine, and you can get that. We also need to know the derivative of e to the x, that it's its own derivative, the derivative of natural log of x, that's 1 over x, and ones that we will see later in the term are some of our inverse trig functions. We'll in particular see inverse sine and inverse tangent. And as we know, there's lots of other rules. These are the ones that I could kind of really think of off the top of my head that we need to make sure that we know.